Hello everyone. The topic of my final project will be about polyethylene and its application in backend products. So basically polyethylene is a polymer, which means it is made up of many repeating units of ethylene molecules that have been bonded together. The process of forming polyethylene from ethylene is called polymerization and is typically require high temperature and pressure, as well as a catalyst to initiate the reaction. During polymerization process, the active center R, which can be a catalyst such as a transition metal complex, react with C2H4 molecule to form an intermediate species. This intermediate species can then react with another C2H4 molecule to form a longer chain, and the process continues until a large polymer chain has been formed. Packaging mat from polyethylene has some following characteristic. First one is the color. Polyethylene can have a milky, opaque appearance or be translucent depending on its thermal history and film thickness. The color of polyethylene helps to prevent light from contacting the food and sun can help protect product from UV damage. Temperature: polyethylene has a maximum tolerance of 115 degrees Celsius for hot and -80 degrees Celsius for cold temperature. It is commonly used for packaging food and other products that are not exposed to extreme temperature. Resistances: polyethylene is durable and flexible, making it an excellent material for packaging and other applications where it is exposed to tearing or chemical exposure. It is also a good electrical insulator and provides good tracking resistance, making it useful in electrical application. Flexibility and durability: polyethylene is highly flexible and lightweight, making it easy to handle and transport. It can be bent repeatedly without cracking at the same point, which makes it durable and long-lasting. Last one gonna be about a cost. Polyethylene is an affordable material, and low-density polyethylene can offer significant saving for high-volume shipping and other applications where cost is a consideration. We have three main types of the polyethylene material, which is high-density polyethylene, a strong and rigid plastic that is commonly used in applications where strength, durability, and resistance to impact are important. The second one, we have low-density polyethylene. It's a flexible and lightweight plastic that is commonly used in applications where flexibility and ease of processing are important. And the last one, we have the linear low-density polyethylene. It is commonly used in applications such as plastic bag, food packaging, and stretch wrap. We're gonna talk a little bit more about the high-density polyethylene. Its high strength to density ratio with the density range from 930 to 970 kilogram per cubic meter. Low degree of punching lead to a strong intermolecular force and tensile strength. Is hard and is more opaque than other type of polyethylene. The melting point typically around 130 to 135 degrees Celsius and can withstand temperature up to around 80 to 90 degrees Celsius for a long term. We can see some example of the product that made from HDPE material, which is shampoo bottle, water pipes, or recycling bin. Next one, we have low-density polyethylene. Its density range is around 917 to 930 kilogram per cubic meter. The melting point is around 105 to 115 degrees Celsius and can withstand temperature up to around 50 to 60 degrees Celsius for a long term. It has more branching compared to the HEBE, so its intermolecular forces are weaker and the tensile strength is lower. Um, when consistent exposure to sunlight, the plastic will produce significantly amount of methane and ethylene. We can see some example of the product that made from LEVE material with such as clear plastic wrap, household garbage bag, or containers. So in here I just a simple calculation. I got the tensor train that was conducted through experiment of the HDPE material and LEB material right here. We also have the data of many blended sample. For HDPE, the tensor train gonna be 27.93 megapascal, and LDPE gonna be 9.93 megapascal. If we assuming the surface area 100 square meter, we can estimate the force at the maximum load at failure of that directly apply on each material, and definitely the force that applying on HDPE gonna be much more higher compared to the LDPE material. The third one, we have the linear low density polyethylene. Its density range is around 917 to 940 kilogram per cubic meter. Has significantly amount of short branches that we can see in the picture right here compared to LDPE, which have long branches and a lot of branches too, and compared to HDPE, which doesn't have much branches and the branches very short. Exchange can slide into each other upon elongation without becoming entangled. Tensile strain ranging from 13 to 24 megapascal based on the specific formulation and manufacturing process. We can see some example. The multilayer film is the most common example right here. That one of the internal layers made from the LLTBE, and then this one is the LLTBE granulars. Here are my drawing of the 3D structure. This one is the HDPE. Uh, so the linear structure of high density polyethylene give it excellent tensile strength, particularly at high temperature. The linear structure of HDPE provide a more crystalline and dense structure, which make the material stronger and more resistant than other type of polyethylene. We have a 3D structure drawing of LDPE. The branching of LDPE occur due to the presence of short side chain in the polymer structure and also some long chain too, as we can see on the picture, which disrupt the linear arrangement of polymer molecule. This branching reduces the ability of the polymer chain to pack closely together and form a dense and crystalline structure, which is necessary for achieving high tensile strength. But however, LDPE is gonna become more flexible and elastic than other type of polyethylene, which make it ideal for use in applications that require high degree of flexibility, such as plastic film coating, or flexible packaging. And we have the 3D structure of LGBE. The reduces branching up in LGBE, allowing the polymer chain to pack more closely together, forming a denser and more crystallized structure. This leads to increase in tensile strain and improve in toughness compared to LDPE. Additionally, the linear structure of LDPE allows for better processability, making it easier to manufacture into various products. And compared to the HDPE, it has more short branches compared to the HDPE 3D structure. And that's it for my presentation. Thank you so much for listening.